Hello students, in this video or the video that I am going to present today, that is focused for different competitive exams like medical and engineering exam. So I will explain numericals based on connected body and motion due to pulley. When pulley is there, how will we solve question based on that? But before that, whenever we are going to solve the numericals, some concept we should have, like the nature of the surfaces, what are the net force acting on the body. For example, if I say, I am going to explain numericals based on connected body. And that is a part of chapter motion standard 11. Rest and motion, no need to write. So suppose there is a question that a 10 kg body is kept on a surface. 10 kg body is kept on smooth surface. What are different forces acts on it? Very important. Numericals, in order to solve numericals, we need to focus some points. Like here a 10 kg body is kept on a smooth surface. So here the question, the body is smooth. That means here we will not focus friction. It is frictionless. And as the body is in the rest, kept on surface, that is body is not motion. So first the force of gravity is acting on the body, that is in downward direction, that is 10 G. You can say it is force of gravity. Actually, I want to give you the techniques that I have got from my teacher. My teacher, when I was in standard 11, and on that time my intention was to prepare medical exam, he said that solve numericals and take concept from that. Nowadays the things are opposite. Students are going through the theory and then they are solving numericals. When I went first time to my physics teacher, he was a very good teacher. He said that, why did you come here? So I said, sir, I want to prepare for medical exam. He said that, okay, you bring HC Verma. We will solve numericals based on that. So I asked, sir, my physics is not good. I want to get knowledge of that, the concept of that. So first let me use some easy books so that I could understand that, and then I will start. He said, no. If you want to study with me, bring that book. First you see any numericals, get concept from that. So that thing I want to say, that when you are going for medicals and engineering exam, in physics you won't expect theoretical questions. Magnetic effect of current and some chapters you will get questions based on formulas, but maximum question based on numericals. So how will we solve numericals? When you solve any numericals, from that numericals you get concept, and that concept is beneficial for you. But before that you must understand that terms. Like in motion, when you are going to study motion, you should know uniform motion, non-uniform motion, rest motion, speed, velocity, average speed, average velocity, retardation, acceleration. These terms you are studying from, you have been studying from standard 9 only. So that is not a big issue. You should understand the concept from the given numerical. So the first question I have given, a a 10 kg body is kept in a smooth surface, what are different forces act on it? So you can say that as the body, as the surface is smooth, so it is frictionless. First conclusion we have drawn. Second, the body is on the surface, so force of gravity will act, that is in downward direction. And as the body is pressing the surface, so this surface will apply an equal opposite force, that is normal. And as the body is in rest, its acceleration is 0. You can say R is equal to mg. Very important conclusion, that when a book lying on the table, it does not move. Why? Because the force of gravity and the normal force that is acting on the book equal and opposite, so the body does not move. Second case, 10 kg body kept on smooth surface. If 4 Newton, 40 Newton of force is applied, then find acceleration of that body. Acceleration of that body. Draw diagram. Draw FBD, that is free body diagram. FBD, free body diagram. So here again the body is smooth. From the first diagram I will explain. The first diagram is sufficient. Here force is acting 40 Newton. So we can say that motion along y direction is not possible. Why? Because normal force and force of gravity both are equal and opposite. This side no force is produced because the surface is smooth. This force is only produced. So net force acting on the body, we can say 40 Newton. A very important concept you must have got in standard 9 class, balanced and unbalanced force. Just you remember, balanced force. If sum total of all forces acting on the body is 0, the body is in balanced condition, the body will not move. And if the sum total of force acting on the body is not equal to 0, the body is unbalanced, body will move. So here the body is balanced in y direction. It will not move. Y direction motion will not occur. But there is a unbalanced net force acting 40 Newton along the positive x direction. So that force will produce acceleration. That acceleration is force by mass. So it is 40 by mass 10. It is 4 meter per second square. This is the second case. In the third case, a body kept on a smooth surface, if 40 Newton of force is applied, then body will not move. Find net force on the body. Second, force of friction. Here one is rough surface. In place of smooth, we can use rough surface. 10 kg weight body kept on rough surface. If 40 Newton of force is applied, then body will not move. Find net force on the body and force of friction produced. This is the diagram. So here the same diagram we can use. Here the body is, force is acting and this surface is rough. Due to roughness, an opposite force will produce on that body, that is called force of friction. And here it is given that body will not move or body does not move. It means the body is in balanced condition. It means you can say that this 40 Newton You can say net force. First you find what is the net force. You can say net force because we don't have idea about friction force, what is its magnitude. It's not mentioned in the book question. So net force is equal to, just we assume this force is bigger than this force. Just we assume that this is called applied force. Mind it? Applied force or force applied. So we can say that applied force, we just assume that applied force is greater than friction force. So net force is 40 Newton minus F. As the body is not moving, it means its acceleration is 0. So net force is also 0, is equal to 40 minus F. So frictional force is 40 Newton. So in this case, here also you can write FBD, free body diagram. Here, this is the free body diagram. If the body is in rest, and if the body is on the surface, rough surface, and after applying the force, body is still not in a condition to move, then we can say that there must be an opposing force. That force is equal in magnitude and opposite in direction. So the net force on the body is 0. Body is in balanced condition. So we can say that this is friction force must be equal to applied force. This is the third condition. Then in the fourth condition we can use we can say a body is kept on inclined plane. Very, very important. A body 10 kg is kept on inclined plane. Its mass is 10 kg. Find the free body diagram of that body. And the body is on a smooth surface. The surface provided is smooth. So the fourth case you can say a body of 10 kg is kept on inclined surface. Angle is, you can take some angle 60 degree. Theta is okay. In this case, we will use component part. Resolving because whenever we are going to solve numericals, we have to solve numericals either in x direction or in y direction. If a body is inclined to a surface, suppose here a body is there or here a force is acting inclined to surface, then we will resolve into two direction. That direction in which theta is there, that is called cos theta, and its opposite direction is sin theta. That is called resolving of a given factor into two different components. So again here will the same thing happen. G will like this, mg. So we will resolve it into two directions. This will be mg cos theta and this will be mg sin theta. So this condition is opposite to this condition. Mind it. When we kept the body 10 kg on the smooth surface, then force of gravity and normal both are equal in magnitude and opposite in direction. So the body does not move. Here we say net force is 0. But in this case, normal force here R is equal to, or N you can use, R or N both are correct. N is equal to mg cos theta. But this mg sin theta will help the body to incline, to move on the inclined surface. So in this case, although the surface is smooth, we can say net force acting on the body is equal to mg sin theta. So its acceleration is force by mass. This is that factor. So mg sin theta divided by mass. So this is g sin theta. Very, very important information. If a body kept on an inclined surface, what is the magnitude of acceleration acting? What is the net force? Mg sin theta. And what is its acceleration is g sin theta. If the surface is rough, if the surface is rough, then another force will produce here, that is force of friction. In this case, we can use net force is equal to mg sin theta minus f, depending upon whether the body is moving down. If the body is moving down, then we can say mg sin theta minus f. We cannot use f minus mg sin theta because friction force can never be greater than applied force. Friction force can be equal to applied force, but it can never be greater than, because this is the tendency of the surface. So in this case, this way we can solve the question. So now I am giving some question based on that part, motion of a connected body, and we will solve it. For example, there is a question, very important. So I have selected 3 questions. First question, 2 block M and N of mass 8 kg and 4 kg. Mass of M is 8 and mass of N is 4 are arranged as shown. They are kept on a smooth surface. So as they mentioned smooth, there is no friction. And if 6 Newton of force is applied on first block, due to which they move with constant acceleration, calculate the force between the block. That means you need to find force between M and N. You have to find forces between M and N. So first we will make FBD, that is free body diagram. Here, force of gravity and normal, that is not important, not required, because I have already explained that when the motion of a body is going on along x direction, it means its y direction is balanced. That is, force of gravity and normal must be equal and opposite. So if you draw the diagram, FBD diagram, then you find that M has 2 force. First is the applied force, that is the 8 Newton, 6 Newton. And this is the force of contact between A and B. You can use R. N has only a single force, that is force of contact. It has only force of contact. This is the R. This is the FBD. Second thing is that the body are connected together. So when 2 or more body are connected, they will have a common acceleration. They will move with the common acceleration. So first you find acceleration is equal to force by net mass. So net mass is mass of M and mass of N. So you can use that force is given 6 and mass is 8 plus 4, that is 6 Newton by 12. 1 by 2 meter per second square, or you can say 0.5. Now what is the net force on M? So M has, as the body is in motion, that means this force is powerful. This is moving. So this force is weak. So you can say that net force is, question is, calculate the force between the blocks. So you have to draw the net force acting on A. M, so you can write F minus I is equal to M into A. For N, you will say that I is equal to M into A. You can here write 8A. Here you write 4A. Both the equations, using any one equation, you can find R. That is, R is the calculate force between the block. As you know the acceleration, so this is good. So put A is 1 by 2. So it is 2 Newton of the force. You can apply here also. Here this formula also you can use to find. F is given 6 Newton. So R is equal to 6 minus 8 into A. 6 minus 8 into 1 by 2. So again 2 Newton. So either using this equation or this equation, you can solve this question. You must remember, when 2 or more than 2 bodies are connected with each other, in this case, they will have a common acceleration, mind it, and a force just like a train moving. So all the bogies are connected with the train, the engine of the train, and the first engine apply force on the second on third like this. This is the force of contact between the two bodies. So in this case, we will first find the common acceleration, then we apply the FBD, free body diagram, and using free body diagram, we will make equation related with it, and then we can find the unknown factor in the given question. Second question, again this is a free body diagram, but it is a little bit different from that because here three blocks are there. Here three blocks are there. So what is the differences that we will see? In this case, so here in this case, first you have to find acceleration of each block. That is common, as the previous case we have taken. Common acceleration. Acceleration is equal to force by net mass. Mass total. Each body has equal mass, so you can write 5 by 10, 10, 10. That is 10 plus 10 plus 10. That is 5 by 30. 1 by 6 meter per second square. Net force on block A. Now we have to draw free body diagram. For block A, this is the force applied. This is the force of reaction. This is for A. So net force is equal to mass into acceleration. So you can directly write net force. No information about the net force. Simply you can say net force is equal to mass of A into acceleration of A. So mass of A is 10 and acceleration 1 by 6. That is a Newton. You can calculate it. The force of reaction between A and B. This is very, very important. When there is a question, you need to find force of reaction between A and B, then we will add B and C. We will consider B and C together. So it becomes 20 kg. It is 10 kg. What I want to say, if we need to find force of reaction between A and B, then B and C mass we will consider together, it is 20 kg. So here we can say that for FBD of A is, you can say, FBD of A is equal to F minus R is equal to 10 into A. Or for this, R is equal to 20 into A. So this is the first equation. This is the second equation. Now the question is, you have to find force of reaction. The net force of reaction between A and B. So in this case, just use this equation. Acceleration, you know, 10 by 6. You can calculate Newton this question. When you have to find force of reaction between B and C, then in suppose you have to find force of reaction between B and C. Here you have to find. Then you combine this together. So you can say that directly we write R is equal to C into A. What is C? It is 10. And what is A? That is 1 by 6 Newton. You can use this also, but no need because this part is easy. If you want to draw FBD, then you can write 20 Newton here. Here is the R. Here is the 5 Newton of force. Here 20 Newton. And for C we use, here is the R. So in this way we can calculate the question. But one thing you remember, if there are 2 blocks, then there is no any problem. But if we have 3 blocks, then if we need to find force of reaction between A and B, then B and C are taken together. If between B and C, then A and B are taken together. Their mass are joined and C is taken separately. In the third question, 2 threads are there. Thread 1 between B and C and thread this between A and B. And force is applied F. Acceleration is given, you have to find F. So here this question and this question both are different, because here force of contact or force of reaction between the body are same. Here force of contact or force of reaction between the two body are different. So again we need to find FBD, free body diagram, and we will calculate. This is important. How will we add? Find F. We need to find F. Here unknown factor is F, not A. A is given. You have to find F. So directly you can make FBD. For this A, you can use for A diagram. This is F and this is TAB. And A is given 0.6. So you can write F minus TAB is equal to 0.6 into A. Number 1 equation. Then for this TAB minus TBC is equal to 0.6 into A. This is equation 2. For this TBC is equal to 0.6 into A. First you put the value of here A, then you find this. Then you put this value here, then you find this. And after putting this value here, you can find F. So first you calculate TBC. TBC is equal to 0.6 into 4, 2.4 Newton. Then you find TAB. TAB is equal to 0.6 into A plus TBC. 0.6 into, in place of A, we will write here it is 4 plus 2.4. So 2.4 plus 2.4 it is 4.8 Newton. Now you put the value of TAB here. So F is equal to 0.6 into A plus TAB. 0.6 into, in place of A you write 4 plus TAB 4.8. 2.4 plus 4.8. 7.2. In this way, we can calculate question based on connected body. Now I will explain question based on pulley. That is very important question, because in competition exam we get question of this pattern. So this is very important. Now I am going to use motion of a body in a pulley, using pulley. So these are the questions that I have taken. There are 4 questions I have selected. In the first question, M and 2M, two masses are on a pulley, taken on a pulley. The second question, M and F is 2mg. Third question, 4 kg and 6 kg. And the fourth question is here, 2 body are taken on, first body on inclined plane. In all the questions you have to find acceleration and tension in each diagram. So when we are going to find or solve question based on pulley, one thing we have to remember that here a string, in case of a string we use tension, and tension always be along the upward direction. As same string is there, same string is passed through a pulley, and from 2 and 2 blocks are attached, so tension will be common. Here tension will be common. It always be in upward direction. Whenever we are going to solve question, mind it, tension always be in upward direction. This is the first information that we have to remember. And then second is FBD. So first we draw FBD of the first question. First block, that is M. Here the force of gravity mg and tension is T. This 2M is more than M. So we will assume that body is moving, this body is moving downward and this body is will move upward. As the two bodies are connected, so they will have a common acceleration. So this is, the body will move up, so here it is M into A. And for the second body, Once you will draw FBD, then it will become easy to solve the numericals. And if you will have experience of that, then without drawing, you can solve the question. This is the diagram. So for the first case, we can write T minus mg is equal to m into A. And for the second case, we write 2mg minus T is equal to 2m into A. Now you add both the equation, first and second. Now mg is equal to 3ma. So A is equal to g by 3. This is the meter per second square. This is the acceleration we can calculate, and you can use this acceleration in equation 1 or equation 2. You can find tangent T minus mg into m into g by 3. So T is equal to mg by 3 plus mg, here 3 mg plus 3 mg, it is 4 mg by 3. In this way we can find tangent. For the second question, we will do the same thing. Here, FBD for the second question. Mind it, whenever we are going to solve the motion of a connected body, free body diagram is very, very important. Once you draw the free body diagram, you can solve the questions very easy. So first question I have explained, this body is going up, this body is going down. Accordingly, I have made the free body diagram, and then we put the equation and we can solve it. So the main part of physics is this. And putting the equation, after that it becomes mathematics, calculation part. Second question, in the second question what is happening here? For the first body, free body diagram is, this mass is given, m is going to be given. So you can write body is moving up, so tensor, here mg. You can write T minus mg is equal to m into A. For the second body, you can write T minus 2mg is equal to 0. This diagram, because acceleration here, using 1, 2, you can solve, find T and E. If we subtract, then we can get the value. Here we can write 2mg minus T is equal to, because this is going up and this will go down. So here mg is equal to ma, so A is equal to z meter per second, and find the value of T. In this case, again, the same thing. Question number 3, same thing. FBD of that first 4 kg body, T minus 4g is equal to 4 into A, and 6g minus T is equal to 6 into A. Add both the equation, that is 2g is equal to 10A. So A is equal to 2g by 10, that is g by 5. Meter per second square, put the value in equation 1 and 2, we can get the value of T. This part is little bit different, because here component part is there, and I have explained that when a body will go on inclined plane, then here m2g sine theta. This part is not required, resolving is not important, no need, but I am just showing this is mg, m2g cos theta, this is r, not important. So here for m2 we will write, we will assume that body will go like this, inclined plane. So we can write m2g sine theta minus t is equal to m2 into A, and for this is m1, t minus m1g is equal to m1 into A. Now you can solve this. m2 minus m2 sine theta minus m1 g is equal to m1 plus m2 A So you can find A is equal to m2 sin theta minus m1 divided by m1 plus. So in this way, we can solve numericals. A answer we can solve, A expression we can solve, and we can put this in an equation. We can find answer. So these are the questions that is going to be very important for you, because once you see the patterns of the question bank if you see of the related exams, you will find that every year you get question based on connected bodies, based on pulleys, and what are the techniques that are used. I have already explained. This is the FBD is very important, free body diagram. And once you understand the free body diagram, you can easily make the equation, and after that you can solve. But the first thing is that practice is important. You have to practice again and again so that you can memorize the FBD, you can understand the FBD and make the equation properly. So I hope you will understand this topic, and this video is going to be useful for you. In the next video, I will do something different. Thank you.